Hi, let's keep going. So now we're going to do exponential distributions. And again, like I said before, they have a distribution where it starts at the top and goes down the x-axis, and it almost looks like a curve. So let's talk about them. So these have to do with amount of time until an event occurs. Exponentials can be done with like bacteria, lengths of telephone calls, batteries, a lot of stuff has exponential distribution. So x for exponential distributions is the continuous random variable since we're measuring time. So let's say the mean is 4 minutes. So for us to have the mean is the best thing that we need to have, because from there we can get the decay parameter. M is the decay parameter. And if you see here, M equals 1 over the mean. So if my mean is 4 minutes, M equals 1 over 4 equals 0.25. The standard deviation is the same as the mean. So that's pretty easy. So if the mean is 4 minutes, the standard deviation is 4 minutes. So how we notate it is X approximates the exponential distribution with M in it. So that's, remember, M is not for mean, it's for decay parameter. So therefore, this one is X approximates exponential with 0.25. So let's keep going. All right. The probability density function is f of x equals me minus mx. That e is that ex button on your calculator. And I put it out here what it is. It's 2.71828182846. If you don't have that button on your calculator, you can always approximate it, maybe do 2.71828 and use that. So for the curve, it is, for the curve that we just saw, f of x is 0.25 e to the negative 0.25x, where x is at least 0 and m is 0.25. So say x was 5, we would plug all this m in into the calculator and get 0.072. But remember, we can't really look at exact values. We can look at ways that it goes. So, all right. So here's a picture of that. Okay, so let's keep going. All right. On average, a certain computer part lasts 10 years. The length of time the computer part lasts is exponentially distributed. So we have 4 questions we're going to ask ourselves. The first is, what is the probability that a computer part lasts more than 7 years? The second one is on the average, how long would 5 computer parts last if they were used one after another? C is 80% of computer parts last at most how long? And D is what probability that computer parts last between 9 and 11 years? Okay, so let's look at the first one. All right, so it's a continuous random variable and the mean is 10. So to do the calculations, my M is the decay parameter and I do M equals 1 over the mean. So 1 divided by 10 is 0.10. And my standard deviation is the same. And you see how I wrote that as the notation. Okay, for the first one, probability is greater than 7. So remember that whole curve that I was looking at is 1. The area under that curve is 1. So what I want to do then is I've got to kind of do an opposite of it to get it to work. So let's do this. I'm going to do, if you look here, because it's the greater than 7, I don't have the n in my part of my formula, and I'm looking right here. Hold on, let me highlight it for you, okay? Oop, yeah. Oops, sorry, I didn't mean to do that. So let me do this. Oops, I don't have it on my computer right now. So this is this one. So what I do is I do e raised to negative 0.1 times 7 to get 0.466, because e is the 7, x is the 7 that I need. So the probability that a computer part lasts more than 7 years is 0.4966. I know there's a lot going on here, so just take it as a grain of salt that I'm showing you the right way. So that was greater than 7. And here is a picture of it, right? For here, on average, how long would a computer part last? So one part lasts 10 years. Therefore, 5 computer parts, if one was used right after each other, would last 50 years. Okay. And then let's do 80%. All right. So for 80%, the 80th percentile, I've got to use the backwards formula basically. So I'm going to use ln, which is natural log, instead of e. So I'm solving it in reverse. So this is what I'm looking for, okay? I want the 80th percentile, which would be k. So I'm going to go here. And then this is the formula for it, okay? It's going to be ln with 1 minus 0.80, which is the total area minus the part I want, divided by, do you guys remember what that is? It's negative 0.1, which is negative n. And I've got it down here of what that is. So that gives me 16.1. So that means how long they'll last is 16.1. Okay? So what is the probability that a computer will last between 9 and 11 years? So again, I'm going to use my formula. So I'm going to do 1 minus e to the negative 0.1 times 11 minus 1 minus e to negative 0.1 times 9. Get those together, and then I subtract. So that's how I did it, because I can't do 9 and 11 and subtract the 2 and get 2. That would get me where it is at 2. So I've got to find both of these and then solve. I hope that makes sense and everybody understood it. If you have questions, let me know.